All right. So good morning. Here we go. Today we are talking about Algebra 2. This is the second day we're using on Chapter 8, Section 4. We're going to graph exponential equations. Remember, we're going to graph logarithmic equations. A logarithmic function is the inverse of an exponential function. What does that mean? We talked about inverses a lot. If I graph the line y equals x, the exponent and the log are reflections across this line. Look at the difference between the blue line and the red line. The blue line, y equals 2 to the x, is the blue line. Y equals log base 2 of x is the red line. Notice the similarities. For the exponential, y equals 0 is my asymptote. It's a horizontal asymptote. For the logarithmic, x equals 0 is my asymptote. What kind of asymptote is that? We're pausing for people to answer, and no one wants to talk on the recorder. Sam, what kind of line is that? Thank you. It's a vertical line. So when we talked about exponential, I had a horizontal asymptote. Talking about logarithmic, I'm going to have a vertical asymptote. Okay? What else do I have that are opposites here? The domain and range. For an exponential function, my domain was x is an element of all real numbers. My range was y is greater than 0, greater than that asymptote. But whenever I talk about logarithmic, my log is opposite. X is greater than 0. Y is an element of all real numbers. There is a limit to what x's I can plug into this problem. Okay? Sorry. Y intersects, x intercepts. The y-intercept was always something key. Anything to the 0 power was always 1. But when I'm dealing with logs, anything to an argument of 1 will always be 0. So here, where I have 0, 1 in blue, I end up with 1, 0 every time in red. That's my reflection. That's the difference between logs. They're opposites. Any questions on this? Okay. I'm going to pause the video. So we were writing down things that were important off of this page. What do I need to know? What's important? This is what I need you to write down. This is something that's key. Things you have to have memorized. Log of 1 is always 0 because b to the 0 power is 1. You need to know log of 1 is always 0. We're going to use that to graph. Log of 1 is always 0. Doesn't matter what the base is, log of 1 is always 0. That's one point we will always have. The second point we'll always have is log of base b. If the base and the argument match, the answer is always 1 because b to the first equals b. This is the second thing we will always use. Log base b of b equals 1. When the argument and the base match, the answer is 1. We can graph these points really easily, really nicely. How are we going to do this? Let's talk about how this works. To graph logarithmic functions by hand, remember, you can't take the log of 0 or a negative number. This will help you find the asymptote. Log base b of 1 equals 0, and log base b of b equals 1. These will help you plot 2 points. So graph number 1. Now I'm going to leave it so we can see those points. Those are good points to know. Example 1. What do I want to draw first? My asymptote. It used to be for exponential, my asymptote was my k. But now that I'm doing logarithmic, what is my asymptote going to be? It's going to be my h. In here, do I have an h? I do. What is it? It's 0. If nothing's written there, it's minus 0, right? So it's 0. So if there's nothing written, it's 0. So my asymptote that I'm going to draw is that vertical line. What is that vertical line? That is x equals 0. Okay? Awesome. I've got my asymptote. But since I have my asymptote, do I have my domain and my range? I do. What is my domain? X has to be greater than my asymptote. What is my range? Y is what? Y is an element of all E numbers. No, yer. Y is an element of all real numbers. That's my domain and my range. I've got my domain and my range. I know that this blue dotted line is my asymptote. So now I want to plot 2 points. X, Y. Looking up at this bullet, what's the first number I want to plot? 1. My first x is going to be 1 because log base, any base of 1 is 0. What's the second point I want to plot? I heard it? I want to plot the point 4 because this is base 4. So what am I doing? I am doing log base 4 of 1 is equal to 0. Anything? Log base anything of 1 is always 0. That's nice. My second point is log base 4 of 4. What is this? 1. So I know that I have the point 1, 0, and 4, 1. I know I'm going to start close to my asymptote and grow like that. That's my graph. I have my domain. I have my range. I have my asymptote. Was there any shifting left and right, up and down of this graph? No. There's no H, there's no K, there was no shifting of this graph whatsoever. Let's look at number 2. Number 2. Again, where is my asymptote? Okay, my asymptote is always the opposite of the parentheses. It's always my H. What is my H? 2. So my asymptote is x equals 2. Awesome. So what just happened? What transformation did I just do by moving that asymptote? I moved right 2, so my transformation is right 2. Is this going to have a transformation up or down? What is it going to be? Stay with me, Michael. What's it going to be? It's going to be up 4. So when I ask you for transformation, it's right 2 and up 4. Okay, so what is my domain and my range? X is greater than 2, my asymptote, and my range is y is an element of all real numbers. Now I can go ahead and I can graph. I can plot my other points and draw my pictures, x and y. Now I'm going to back up. Y, x, do that better. This is x minus 2 I'm going to put in the middle. This is the argument. What do I want the argument to be? Well, going back up to these bullets, I want the argument to be 1, and I want the argument to be b. So I want my argument x minus 2 to be 1, and I want it to be my base. What's my base? 3. But if I want my argument to be 1, what does x have to be? X has to be 3. What does my x have to be if I want my argument to be 3? It has to be 5. So I don't need this middle column anymore. And I'm going to do log base 3 of 3 minus 2 plus 4. Well, what's 3 minus 2? 1. What's log base 3 of 1? 0 plus 4 is 4. Every time. Whenever the argument is 1, the log is 0. Let's try 5. So we're saying log base 3 of 5 minus 2. What's 5 minus 2? So log base 3 of 3 is plus 4 is 5. So the 2 points I'm going to plot are 3, 4, and 5, 5. So I start down, and I come off. There's my graph. So my asymptote is always y equals or x equals. For logarithms, it's always x equals. Because of that, domain or range, which one is an element of all real numbers? The y, the range, is an element of all real numbers. The domain is what is limited. I'm going to pause. Up to this point, can you do any of these graphs by hand? Are we capable of doing these by hand? Yes, if we want. If I say no calculator on the quiz or the test. Can I do these in my calculator? The answer is yes, and so that's what we're going to do for 3 and 4. All right, so now we're going to do some graphing. We're going to graph my other 2 problems, but we're going to graph them using the calculator. Remember, when you're taking a quiz or a test, are you going to be able to use any base I want? No, you have to use log base 10 or natural log. So to do 1/2, to do this log, what do I have to put into my calculator? So this is at the bottom of yesterday's note sheet. It's a change of base formula. If I have log base 1/2 of x, to make that into like any base, it's going to be log, I'm going to assume base 10 of what? X, my argument, divided by log base 10 of my base. This is what I need to type into the calculator, plus 3. Okay, so I'm going to go to my calculator, and I'm going to make this bigger. Log x. So under F1, I'm going to hit log. I'm going to hit control log. I'm going to assume base 10. And it's log, it was of 1/2, so 1 divided by 2. That's wrong. I'm sorry. The first log needs to be my x, my argument, x. I'm going to divide this by log of my base, 1/2. After I do that division, I want to add 3, because that's what the problem said. I'm going to hit enter, and this is what my problem looks like. Now, do you trust me? Do you trust me that I did this correctly, that I didn't make a mistake? Does that look right? That doesn't look right to me. What did I do wrong? Okay. How do you check this? Let's see, where is my mistake? Because something doesn't look right to me. I can go to log base 1/2 of x plus 3. Now, if I did the original problem right, should I see a different graph, or should I see the exact same graph? Should be the exact same graph. And if I hit enter, it's the exact same graph. So why was my mind going nuts? Because this is logarithmic decay. It's the inverse of exponential decay. Instead of starting low and going high, that started high and went low. This is right. This is okay. Can I do this in my calculator if I'm in press to test mode?
No.
Yes. Not what I did in red, but what I did over here. What color is this? Blue or purple? Blue. This over here in blue, I can do that. Questions? Okay. How do I graph this once it's in my calculator? Your teacher wants to see points plotted on a grid. How do I find it? Do you recall? Hit the menu button. Go to what number? Number 7, table. I want to do a split screen table. I can plot the point 1, 3 and the point 2, 2. What's my asymptote? What's my asymptote? X equals 0. Questions on this? Can you do this? How about natural log? Do I need to do the natural log? I don't have time to do the natural log. So everyone, say bye to Leah.